So a very good morning, students. So as we have been looking at equations and identities, today's case we are going to look at equations involving surds, as you are seeing here, equations involving surds. And the other time we are looking at surds, where we say surds, these are irrational numbers which cannot be simplified to its simplest form, or numbers which have no exact square root or exact cube root. We call them their surdic numbers. So we have said that equations involving surds can sometimes be expressed in the polynomial form by calling that this one has a degree of this. So we are going to be looking at these examples, which I want you to follow critically and very sensitive on these ones. If you have a person who is disturbing you, better change the place or tell the person, hold on, I first understand these concepts. We are going to deal with these examples where we have the first one is saying that solve the equations part A, root of x plus 13 minus root x equals 1. Part B saying root of 3 minus x minus root of 7 plus x equals 2. Part C saying root of 4x minus 1 plus root of 2x minus 4 minus 1 equals 0. Part D saying root of x plus 6 minus root of x plus 1 equals 1. So we want to start with that. We are going to start with part A. We are looking at the solutions. We have got root of x plus 13 minus x equals 1. So what we do here, always rearrange first. Those ones which are in a surd form or which are under root should be together. Those ones without a root, which are non-surdic numbers, also put them together. So what happens, we are going to have root of x plus 13 equals, take that one, that side is going to become x plus 1. So how can we remove that square root? Is by squaring on both sides. So you can say squaring on both sides, squaring on both sides, squaring on both sides. So we are going to have root of x plus 13, the whole of it squared, equals x plus 1, the whole of it squared. So can we apply, where we see these identities which we have been talking about, use Pascal's triangle to expand and come out with a clear value. So a square crosses with the root. We are going to remain with x plus 13 equals, expand that one, it's going to bring x squared plus 2x plus 1. Then can we rearrange it, arrange that equation very well? We take these ones in the other side. We are going to have x squared plus 2x minus x plus 1 minus 13 equals 0. So we are going to have x squared plus x minus 12 equals 0. This is a quadratic equation which can be solved using all the 3 or the 4 methods which I taught you. So but for this case, I will only use what we call factor method. So we look at the product and the sum, and at the same time we also look at the factors which can easily be substituted there. So the product is negative 12 and the sum is 1. Think of two numbers. When you multiply those two numbers, you get a negative 12. And when you happen to add those two numbers which you have solved of, you will come out with a positive 1. For my case, I see we have negative 3 and a positive 4. So we substitute in, we are going to have x squared minus 3x plus 4x minus 12 equals 0. Two numbers in a bracket, two numbers there. We go ahead with the factorization. What is common is x into x minus 3, and what is common here is a 4 into x minus 3 equals 0. So what are we having? We are having x plus 4 into x minus 3 equals 0. We are going to say either x equals negative 4 when you take that one there, or x equals 3. These ones are not enough for you to go with. When you are dealing with numbers which are under surd, we do in this stuff. Through testing, go by checking. You may find that the one which has come out may not bring the exact answer there. You say checking, or we are testing the equations, testing the equations. We want to see which one is correct and which one is not correct. So we are going to test through here. So we want to check, are they bringing the exact thing? Are they bringing not the exact? So we're going to start for x equals -4. What does it mean? We want to see on the left hand side if it is bringing what is in the right hand side. Anywhere. Can we test there? We are going to say the root of, where there is x put a -4, we say -4 plus 13 minus -4 if it is bringing 1. Can we test if it is bringing 1? This one they collide. -4 plus 13, it is like 13 minus a 4. 13 minus a 4, you automatically get a 9. So we are having here the root of 9, then plus a 4. What is the square root of 9? It is bringing 3. 3 plus 4, you come out with 7. Therefore, the left hand side is not equal to 1. That means x is -4 is not right, much as you got there, but when you are making your conclusion, it will not be put there. So we have already seen it is not equivalent to that. We also go for x equals 3. For x equals 3, can we substitute in? We are getting root of 3 plus 13 minus 3 if it is bringing 1. 3 plus 13, you are getting root 16. Root of 16 minus 3. What is the square root of 16? Is 4 minus which is 1. So 1 equals 1. That means the value which is correct here is a 3. You say therefore x equals 3. So it's the rightful solution for that. So as we are trying to see that the first part has brought that one, so we are going to move to part B, and we also see, we test for convenience, the one which is correct. So we are moving to part B. We want to get the solution for part B. We need to get the solution for part B. We need it seriously. Let's go to part B. Part B saying root of 3 minus x minus root of 7 plus x equals 2. So there are two ways of killing this bird. You can, is a square this one, you can first take that one the other side. So what I'm going to do, let me take this one just so that the roots are not much and they can easily confuse you as a learner. So we are going to have root of 3 minus x equals 2 plus, because this one is a negative, when it goes in the other side it becomes a positive. 2 plus root of 7 plus x. So we also say squaring on both sides, squaring on both sides, squaring on both sides, squaring on both sides. What do we have? We are having root of 3 minus x equals 2 plus root of 7 plus x. Then we are squaring. We are squaring. And here, but recall this idea here. Recall a plus b squared. What we did, because you can see a is this one is standing for b. What was this one expansion coming out? Was a squared plus 2ab plus b squared. So what I'm going to have, when you square this one, I'm remaining with 3 minus x equals, square this one, when you expand using this idea, 2 squared you are coming out with 4 plus 2 times 2, I'm getting 4 root of 7 plus x, then plus the whole of that one squared, you're getting 7 plus x. We are substituting in that. Then we go ahead and we also first collect like in terms. So what we're going to have, we're having 3 minus x equals 4 plus 7, I'm getting 11, 11 plus x plus 4 root of 7 plus x. We collect like terms, we bring them this side, so I'm going to have 3 minus 11, I'm going to have 3 minus 11 minus x, again minus x on one side equals 4 root of 7 plus x. So what is 3 minus 11 class? 3 minus 11, I'm getting automatically negative 8. Negative 8 minus 2x equals 4 root of 7 plus x. Still, what is common? What is common is a 2. 2 can be divided everywhere. Divide out by 2, I'm remaining with negative 4 minus x equals 2, the root of 7 plus x. So how can we remove that root? Squaring on both sides again. You see, squaring on both sides, squaring on both sides, squaring on both sides again. So we are going to have negative 4 minus x, the whole of it squared. Then we say equals 2 root of 7 plus x, the whole of it squared. So when we square, what are we going to have? We are going to have 16 plus 8x plus x squared equals, this one becomes 4 into 7 plus x. Then from there, we are free to rearrange our equation after opening the brackets. So we can go ahead and we open our brackets as we rearrange them. So what was our equation saying? We are having x squared plus 8x plus 16 equals, open 4 times 8, that is 28 plus 4x. So we collect like terms, we are getting x squared plus this one comes, we are getting 4x. Then we have got 16 minus 28, we are going to get minus 12 equals a 0. So we look at how can we factor out this number. Think of two numbers, when you multiply them, you get negative 12, and when you add, you get a positive 4. According to me, we have got negative 2 and a positive 6. So we are going to have x squared minus 2x plus 6x minus 12 equals 0. Go on, go on. So what is common is x into x minus 2, then plus 6 into x minus 2 equals 0. So we are having x plus 6 again into x minus 2 equals 0. So what we're going to do, we are going to have the values. That means either x equals -6 and x equals 2. So I've got two values of x. But this is not enough. I said go ahead and test for convenience. Test the one which is correct. If all of them are correct, then you are free to make your clear conclusion. We are now on testing. The root was root of 3 minus x minus root of 7 plus x if it is bringing a 2. Once if left hand side is equal to the right hand side, you start by substituting in For x equals negative 6, we substitute in, we get root of 3 minus 6 minus root of 7 minus 6 if it is bringing 2. One see that this and this, they become root of 9 minus root of 1. Square root of 9 is already 3 minus 1, which is 2, which is okay. That means the value for x when it is negative 6, it is working. We want to also go ahead and test for, we're also testing for x equals 2. So I've seen that for that is also coming. We also go for x equals 2. Substituting, having root of 3 minus 2 minus root of 7 plus 2. So, because that's what we are substituting, then this is the root of 1 minus root of 8. Automatically it is not yielding the other one. So this one is not equal to 2. So being rejected. So therefore, the correct value is x equals negative 6 is our solution for that kind of the number. So I will do for you part C or part D. Then let me do for you part D. Then part C is yours. A serious learner should do all. But for me, I will do for you the last example because we have already tried to do more. And I beg and I request, go and open your backhouse book. You do more numbers, or you can open your pure understanding pure mathematics. Then you will achieve the best when it comes to this very